Alright students, so today we are going to go over the properties of circles and go over some terms. So one thing you guys already know is radius. A radius is a segment from the center of the circle to the edge of that circle. So this center, let's call this center O, to the edge, we have radius. Alright? You can go in any direction. If I have a segment from one side of the circle to the other side, and it passes through the center, we call this the diameter. All right, so diameter goes from one side of the circle to the other, and it passes through the center. If we just have a segment that goes from one side of the circle to the other, but not through the center, we call this a chord. Okay, this is a chord. It's a segment with two endpoints on the circle. Theoretically, diameter is also a chord. If we have a line that goes through the circle, meaning it intersects the circle at two locations, we call this a secant. And the difference between a secant and a chord is that the chord is only a segment. The secant is actually a line that goes through. If we have a line that intersects the circle at one location only, one location, we call this a tangent. All right, a few terms to consider. This is the introduction to basically circles and the unit on circles. If I have two circles that intersect in one location only, we call these tangent circles. All right, they intersect in one location. Here I also have one location. All right, so both of these are examples of tangent circles, meaning they only intersect at one point. If I have a line that touches or intersects only one location of two circles, like so, one location of two circles, and if it's between the two circles, we call this an internal tangent, because it's touching one point there and one point there. It's intersecting the circles at one location, and it's between them. If I have a tangent that it's on the outside, then we call this an exterior tangent. All right, it's a line that intersects one point of a circle, one point of another. We call it exterior, and it's on the outside. Let's say that I have, let's call this line here, line L. If line L intersects the circle at the radius, this is the radius, then this is a 90-degree angle. Again, if line L intersects the circle at one location and it's also intersecting the radius, this is a 90-degree angle. This is actually a theorem. Your book calls it 10.1. This is irrelevant. Just know that if this line is intersecting the radius at one point on the circle, then they are perpendicular. And if we look at its converse, working backwards, if this line here is perpendicular with this line here, with this radius, that means that that is a tangent. Okay, and we can use that property or that that theorem to solve for missing lengths. For example, here, this is a right triangle. Let's say this is A and this is R, I guess, and this is this entire segment here is M. So all that is M. You can do R squared plus A squared equals M squared. Okay, this is going to come up in your homework. Just keep that in mind. All right, so this is the summary of Introduction to Circles. There's one more, I almost forgot. If I have a point on the exterior of the circle, point P for example, and from this point I have two tangents going to the same circle, then I can say that this is the same as that. For example, let's say that this here, this is A, P, and this is, I don't know, let's call it X. We can say that AX is congruent to XP. And so if this is 3X plus 5, and let's say this is 20, I can solve for X. 3X plus 5 equals 20. Subtract 5 on both sides. 3X equals 15. Divide by 3 on both sides. X equals 5. All right, guys. Hopefully this makes sense. Let me know if you have any questions or comments or any other videos. All right. Thank you. Have a great day.